All right, so now we're gonna go ahead and check our work from this last activity. So the first question it asked you is the expression 10 plus 78t minus 16t squared written in standard form? Explain how you know. So I'm gonna talk through this. I may not write every single piece out, but you can still go ahead and check your work. So the answer to number one is yes, it is. This is still written in standard form because I have my three terms here. Even though not all three are needed, this quadratic does have three terms. And the most important here is I have my t squared. I have a variable squared, such as x squared, but in this case it's using a t. So I know this quadratic is written in standard form. Then I have my ax squared term, my bx squared. I'm saying x, but this quadratic is using a t, so my 78t term, and my constant term here. So yes, this quadratic is written in standard form. The key feature here is that we have a variable squared term. A variable squared term. So anything to the power of 2, that's my indication this is in standard form. Now, number 2, it says, Jada said that the equation g of t is equal to negative 16t minus 2 times t minus 5 defines the same function as this original quadratic in standard form here. So we need to show that Jada is correct. So Jada is correct, now we need to show that. And we're going to show that by expanding this out using box method or distribution property to show that this is equivalent to this. So how we're going to do that is we're going to expand that out. So I have negative 16t minus 2 times t minus 5. So I'm going to use a distributive property here. So I'm going to start with my outer term. In my first factor, I'm going to multiply that by t. So negative 16t times t, we now have 2t's. So it's negative 16t to the power of 2. Then I'm going to multiply negative 16t times negative 5. And 16 times 5 is 80. Since it's negative and a negative, when multiplied together it becomes positive, so that's plus 80t. And now I'm going to use my second term in the first factor and multiply by both of the other terms as well. So I have negative 2t, negative 2 times t is negative 2t, and then negative 2 times negative 5. Again, they're both negative. A negative times a negative is a positive. So negative 2 times negative 5 is going to be positive 10. My last step is to combine like terms. So here I have no other term with a power of 2, so this is by itself, negative 16t squared. Then I have positive 80t and negative 2t. These are my like terms because they both have a t to the first power here. Positive 80 minus 2 is positive 78t, and then I'm lastly left here with a positive 10. So by expanding this out, I have these three terms. You can see it's equivalent to this one up here. It's just simply in a different order. The 10, I have a 10. I have a positive 78t. I have positive 78t. I have a negative 16t squared, negative 16t squared. We have now shown that Jada is correct by expanding this out. They are the same. Now it says here's a graph representing both negative 16t minus 2 times t minus 5 and the original. We already know they're equivalent. They're the exact same function, even though one is written in factored form and one is written in standard form. And then here is our graph of that quadratic. Now it says, identify the approximate vertical and horizontal intercepts. What do these points mean in this situation? So my vertical intercept is on my line going up and down, my vertical line, my y-intercept. Here is my vertical intercept. It's at 0, so the x value is 0. The y value is halfway in between 0 and 20, so it's at 10. So it's at 0, 10. Then my horizontal intercept, my x-intercept, is right here. This is where it's touching the x-axis. It's the only place where it's touching the x-axis. And so again, to label that coordinate point, I do x value first. So it's x value 5, y value is 0. We don't go up at all. So it's at 5, 0. Now, what do these points mean in this situation? Here, if I'm throwing an object up, this is my starting point. It is starting at a height of 10. We also remember that given a function in standard form, the constant value with no variable is the initial height. So it has an initial height of 10, so I'm going to label that initial height of 10. Initial height of 10. And then it's thrown up into the air and then it lands. So this is my height, this is my time. Remember, your inputs, your x values always are time. So that means that after 5 seconds, our time is in terms of seconds, 5 seconds later, the object landed on the ground. So the object landed after 5 seconds. I'm going to go ahead and write that. Ooh. Pen's not working. All right, so there we go. Oh man, it's not working. All right, so I'm not going to write it. Difficulties here, but this point, what does it mean? It means that 5 seconds after the object was thrown up into the air, it landed back on the ground.